My name is Arun Hariharan. This is Anand Kamath. We're from Sabre Holdings. And first, thanks for sticking around for the last presentation. Um, at Sabre, I'll probably just go through basically what we do and what we use Couchbase for. And after hearing all the online gaming and the online gambling, social gaming and everything, we're taking a step back. This is kind of going retro. We're trying to take some of the mainframe functionality that we have, that Sabre has incurred technical debt over the past 40 years or so, and trying to move it to more newer technologies. And Couchbase is obviously one of the partners for us to do that. So, so just a brief overview of what Sabre does. It's a global travel industry company. It does, we host major airlines, all their fares, schedules and all that. And it provides basically a venue for travel agents as well as online travel sites to pull out content from the mainframes, and also some open systems products which actually host the data. So these technologies, obviously, it's on a massive scale. It's accessed by about 1 billion people, I guess. So, okay. So back to what we use the product for, what we use caching solutions for. So I wanted to step back and provide an overview of basically why we need caching and what we cache. Over time, a lot of the functionality that Sabre provides is maintained in the mainframes. And this is an IBM mainframe, a customized version of an OS 390 that was built back in the 60s or early 70s with American Airlines. And most of the data and all the functionality was in the mainframes. So over time, say starting around 2000 or 2002, Sabre started to pull out the functionality from the mainframes on open systems, commodity hardware. While the functionality was easy enough to pull out, the state, the session of the user sessions and the state of the application, all of that was still in the mainframes. And the reason for that was quite simple, because at the time, it was the fastest, massively concurrent transaction engine that there was. And in order to go long times without restarts, it was extremely high latency, and that was the preferred choice of technology at that point. So now, access to data or session data in the mainframe is extremely expensive, because the cost is measured in terms of the path length and the instructions per second that actually happens on the mainframes. So then the next logical step was to take all that data and cache it in an open systems layer. So so that the access to the database is minimized. But that brought its own unique challenges, in the sense that there's 2 copies of data, one in the cache and one in the mainframe. And the mainframe data is also changing, and there's only so many, a subset of it that gets notified out to the open systems. So we had these issues and challenges, and so for any of these caching solutions that we prototyped or did a proof of concept, the main things were we had anything that we prototyped had performance limitations. There was latencies, and if it was a Java-based solution, we had to contend with garbage collection, distributed garbage collection. It was not possible to scale horizontally as traffic exploded. And if there was a clustered solution, there was always a problem with cluster restarts or application restarts. So if we had to update the OS, the kernel, the OS of any one box, any one node in the cluster, we had to actually shut down the cluster and restart the cluster. And all this was not very ideal for, say, a production environment where we had to stay up 24/7. So, oops, okay. So we came up with a set of requirements. So we broke down our use cases to applications that needed a transient cache. It's a pure cache. There is a backend data store. It might be the TPF, the mainframes, or it could be a database. For that, we probably could just use a memcache bucket. There was also a recoverable cache that we needed to have in place where that is the actual data store. So, and for both of those requirements, we found that after, looking at different database, different NoSQL solutions, Couchbase was the one that actually gave us both these options with a lot of, I have to say, manageability and instrumentation came out of the box, and that helped us really. So we had to be highly available and consistent. So we, in the CAP theorem, in that space, we had to be consistent and also high availability and partition sharding. We had to have that in place. And one of the other things was we had to have a high level of linear scalability. We had to be able to add nodes and also remove nodes as and when capacity changed in order to be able to reasonably serve our customers. And also, we do have multiple data centers. And so disaster recovery for critical applications was, of course, to start with, that was a requirement. And of course, all of this we had to do at extremely low cost. And when compared to mainframes, anything is lower cost, but we tried to stay away from high expensive commercial products. And we've been through a few iterations of testing out with different commercial products, and we probably ultimately stopped at Couchbase. We've been using Couchbase for about 6 months. We're not yet completely in production on any of these systems, but we expect to be in production, say, end of the year or early next year is when we're scheduled to go put this in production. And we're going with 1.8.
181.
181. Yeah. So I think Anant will go over the use cases that we have that we're just prototyping and what we have in place. Okay. You want to take over?
Yeah, thanks. We basically had many use cases, and the main one that Arun mentioned is getting the session data from the TPF systems to open systems. So the first one, the use case we had was for session cache. The real session manager is still in the TPF mainframe, but we wanted to create a cache in open systems. So for that, we wanted a transient cache. We just store one type of data, that is a session data. But the throughput was very high. We had to plan for at least 8,000 transactions per second, because that's the rate at which the transaction volumes are increasing in Sabre. So like the transactions to Sabre comes from travel agents, web services, B2B applications, and many other systems. So the session cache was the first use case, and this is something that we're working towards, and it'll be in production pretty soon. The second use case is an application data cache. This is like an enterprise cache for many applications within Sabre. So in Sabre, we have, for example, we have flight applications that deal with flights. There are applications that deal with cars. There are applications that deal with hotels. And they build systems individually. So, but there is a need for them to share information. So the application data cache is like an enterprise cache for components within Sabre. So that's the second use case. And for that, it can either be a transient cache or a recoverable cache. So it's either type. And the good thing about this is with Couchbase is you can configure a Couchbase with a memcache bucket or with a Couchbase bucket. So you can do both. So that was a kind of a good fit for the application data cache. And I'll go in detail in all these three use cases. The last use case is a session manager. This is actually, we are kind of evaluating it right now. And one of the key things we are interested here is in the Couchbase 2.0. We are waiting for that release because we have multiple data centers. And we are not in Amazon cloud, or we're not in the cloud, but we have our own private data centers. And it's important for us to for the data to be available in both data centers, especially for the session manager. So the third use case is basically replacing the session manager in TPF with an open system session manager. And for that, I mean, the requirement, it has to be recoverable and persistent. It has to be multi-tenant, and the throughput is, again, has to be greater than 5,000 TPS. TPS stands for transactions per second. Let's go in detail one by one use case at a time. Yeah, the first use case is a session cache. So with the session cache, today the session manager is on the mainframe. We also call it the TPF system. Now the TPF is a system that IBM built for Sabre many decades ago. So this TPF system is kind of, it's got its own operating system, and it's meant for transaction processing. So it's like a highly customized system for Sabre that was built in 1970s, somewhere in that range. The session manager, basically, one of the key things that has got high, it has to handle high volume. 5,000 TPS is what we expect, the volume it handles today, but the latency is very low. So this is one of the key reasons we didn't find any good alternative for replacing, a mainframe with an open system. And we tried different applications like open source software that was built with Java. I mean, it was not really a good fit for us because the latency was very high. It was not in the range that we were looking at. But with Couchbase, we really saw like sub-millisecond latencies, and that's what we liked. I mean, it was close to what we saw with the mainframes, comparable. Like everything with Memcache, when you make a get or put with the 8K load, we were seeing like sub-millisecond response times. Again, one of the things that Sabre is looking at is to reduce cost, okay? And the transaction cost for Sabre, I mean, Sabre incurs cost in the way the cost model works is for instructions per second that's executed in mainframe, Sabre is charged. So IBM charges Sabre a truckload of money for any software you put in mainframe, and if it takes a lot of CPU cycles, then we call it like million instructions per second. So that's how they compute. So that adds up, and we really can't put new applications on Sabre on the mainframe, and the cost is really high. The problem is getting data out of mainframe to open system is also expensive, because anything you write to get the data out from mainframe, even that has to incur this transactions per or the cycles on the mainframe, and that's very expensive. So we really need to, we're looking at replacing this total session manager out of mainframe and totally into open system. But the first step is the baby steps. We are looking at creating a cache first and reduce the initial costs. So what is unique about the session? The session is same as like any web session. So you have, in a web session, you have like a JSession ID. So you have a session ID. So even in Sabre, with the way the session manager was designed, it has got a session ID, and which is unique for each session. And the session object itself is around 8K size, so it's a very small object. And if the user is inactive, it expires. So this, in our case, our user would be a travel agent sitting at his desk, and he goes out for lunch or something and comes back. He has to restart or start over, logging into the system again and starting over. So that's the inactivity time. And it fits well into a caching solution where, like, for example, a Couchbase, I mean, when we store data, we can store with a time to live. And for the session cache use case, we are looking at storing the data for only around 7 minutes time to live. Typically, the user inactivity time in Sabre for a travel agent is 15 minutes. So for the cache, we're looking at half of that. So. Okay, so this is the block diagram, of representation of like the data flow. So at the very top, we have the mainframe system. We call it TPF, and we have a session manager over there. And we have gateway system. The gateways are the open system applications that we have built for the past many years. So there is a web services gateway. So B2B applications or app developers can use the web services to get flight information, get hotel information, and things like that. And they come through the web services gateway or the terminal gateway. The travel agents are used to like an Emacs or very old VI editor. So they're used to that set of commands, and they enjoy typing those commands. So those are the travel agents, and they come through another gateway in Sabre. And the third one is kind of the latest, the mobile gateway. So that is still, we see some increase in traffic there as well, data coming from Travelocity and places like that. So these are the three gateways, and each of these gateways have one thing common. I mean, whenever somebody enters the gateway system, they have to create a session. So the gateways would go to the session manager to say, create a session for this user. So that would be a direct call to a mainframe system, and we have each time the gateway or any of the applications goes to mainframes, it's like a tollway. We have to pay a toll for getting in and out. So that's not where it ends. I mean, gateway is just a router. So all the transactions coming through the gateway are routed to the core applications. So you have many core applications, tons of them for hotels, for car, for pricing, shopping, all that. So the gateways would then send the transaction to the core applications, which again go to the session manager. So it's a double hit. So anytime anybody goes to mainframe, we get a huge, hefty bill to pay. So one thing we looked at is, the session data. So whenever the first time we create a session, if we cache that data, so that is substantial cost savings because we have the data in open systems, and we don't have to go back to mainframe all the time. So the next picture, next slide. Yeah. So this is what we did. So we currently have a caching system in place, which we'll be replacing with Couchbase because of some of the limitations that Arun mentioned with GC and other things. But basically, the idea is the gateways would, first time when a transaction comes in, it goes to session manager, gets the data, and then it'll go and store that session in our, what we call a distributed session cache framework, which is an application that has, for example, a Couchbase client API to handle the data. But what we do in Sabre is we usually use an enterprise bus. So the queue, what you see there is basically a bus. So any application that wants to use or wants to store or retrieve sessions would go through the bus. So the gateways, terminal, the web service, terminal, mobile, as well as the core apps, they go through the queue to actually retrieve or handle sessions. So what we have done is we have reduced the traffic going to the mainframes this way, and we always go to the open system, the caching solution that we built. So we actually anticipate a lot of reduction in hits to the mainframes, and that itself will save a lot of costs for Sabre. And we are talking about 5,000 transactions per second to 8,000 range, and if you calculate that over a period of a year, it's substantial. So it's a lot of savings. Okay, the second use case that we are looking at is an application data cache. So this is totally separate from a session cache. So what we are trying to do is, within Sabre, we have many applications. Travelocity has got a set of applications, and other business units have their own applications. And there is a need for them to build applications quickly, but not worry about storing and retrieving distributed data. So what we are doing is we have the same application cache framework running behind the bus. And in this case, it's not just storing the session data, it stores all kinds of data. So the application A, which we have not really mentioned here, but they are kind of internal to Sabre. So they, for example, they do the hotel shopping, for example. So the hotel, the airport codes and the hotel names and other things can reside in the Couchbase. And the good thing about the Couchbase is we can have multiple buckets. So for each applications, the way we have deployed this is, or we are planning to deploy this is, we plan to have separate buckets for each of the applications. If they are not sharing any data, any keys, then they can have their own independent buckets, individual buckets, and that way, we isolate application A's data from B. So we are providing an enterprise bus for applications to store, but on the other side of the bus, it's the same application doing storing and retrieving data. So this is another use case that we're looking at, and we don't expect a lot of transactions per second through this, but we do expect various data sizes that application A, B, and C will be storing. So we are just reusing the previous use case, whatever we built there for this as well. Okay, so this is, like I just mentioned, the application cache is a regular key value store. User has they have various payload sizes. And the way we want to configure this is we'll have a mix of a transient and a persistent data caches, like a bunch of memcache buckets and Couchbase buckets working together. And it's really meant for a multi-tenant environment. So you'll have many different type of applications that can connect to the bus and make use of the data. So, but we do have, when we tested with the Couchbase, one thing we looked at is we don't want one Couchbase bucket to impact other buckets. So we are actually creating our own file system, a local file system, and so that it's bounded and attaching that to that particular bucket. So we are looking at isolation, and one way we found we could do isolation was by creating its own hard disk or partition for each of those buckets at the local disk level. We also, in our testing, we found that when we have a lot of data, the recovery was taking a while at least. But one thing that we tested during our in our lab is basically with the RAM disk option. So instead of the local disk, you can even give configure a RAM disk, and that really improved the replication, but whenever there is a failover of one node, the data moved faster or the recovery was faster. But this is just something that we did in our lab environment. Not really, we have not decided about production yet. So, okay, so this is a set of examples on what we plan to do with the application cache. So there are some deals that we plan to store. So the deals have fixed expiration time. So for example, anything on Travelocity, some promotion on Travelocity lasting for 24 hours, those deals will be in the cache, and and when it expires from the cache, the deals are off. So that's a good fit for what we are using it for. But that's a kind of a recoverable cache that they'll be using. So we also have hotel promotions. So we can look at what the user has booked previously, and we can store that information and present it next time they come. So we can use some of the user behavior to present promotions, and a bunch of like it's like a regular cache, like the hotel property details, the airport city codes, and currency conversion. So these things don't change often, and so it's in the applications can actually use the cache rather than the actual database. So earlier the applications were using a real physical database, and so it's been replaced by cache. So these are the uses of application cache. Yeah, Arun will talk about the future plans. So.
Yeah. So actually, when we had ROIs on exactly how much we would save, and we had business plans built out. But since nothing is in production, I don't think it'd be appropriate to share that information. But it is a big deal at Sabre to be able to just put in commodity hardware and take load off of the mainframes and expensive database racks to be able to actually save the company some money. So it's a process of selecting what is a good fit for use with Couchbase, and we are almost every week we are finding places where we can actually put in Couchbase and actually save money in terms of, it's not only the money, it's also about operational ease as well as efficiency in the enterprise. So looking ahead, we do have this session cache, which we would, in addition to using it as just a transient cache, we'd probably go one step further and use it as the actual session manager, so that in order to recover sessions, we don't actually have to go to the mainframe if it's not available in the cache, but the Couchbase system itself is the owner of the user cache data, user session data. And then the next logical step is to actually store large data sets. And I think we're talking to Couchbase on you guys with the 2.0 release, which has some opportunities for us to explore there. And of course, XD CR is also a big deal for having data recovery and disaster recovery. And so those are kind of what we are planning to do. That probably be over the next year or so. So maybe next year we'll have a larger story, a larger set of things that we're probably working on. We've been working for 6 months, and the experience has been good so far. So that's kind of where we are at Sabre with Couchbase. So do you have any questions? So the question was, have we considered using Couch for live data, for data that's changing pretty often? And yes, we do. The session data is actually, it does change pretty often because of the way the travel agents actually use it. So when a travel agent logs in, he is logged in, let's say he's booking in on behalf of a business customer. So if it's an Amex customer, so Amex has access to a set of fares, and then now he's on the line and some other business customer calls in. So he has to change over to that business partner's data, all within the same session. So even though the session is actually stored in the mainframe, the context within the session changes, and those changes have to be replicated in the cache. So it is live data, and so our first use case is to access live data that's changing on the fly. We actually don't use it as a document database. It's just a key value store. So there are different, like we had earlier, those gateways coming in, right? So there are different protocols for those, each of those gateways. And as soon as they come into the system, they're normalized into a standard data format for use within Sabre. So the data that is actually stored in the key value store is a canonical format that with metadata indicating which stream it came in from. So we actually normalize the data within the enterprise. So hope that answered.
Okay.
Any other questions? Cool.
All right.
All
Thank
right.
you, guys.
Thank you. Thanks.